I will start with me. My name is Alexandra Silva. I work in CECIL. CECIL is a cement Portuguese company. I work since 2005, mainly in the area of quarry rehabilitation and biodiversity. We have here today a big team. We have Alice Nunes and Helena Serrano from the Faculty of Science of the University of Lisbon. We have a partnership with this university, and we also have Pedro Salgueiro, Carmo Silva and Ana Sampaio from the University of Évora that also have a partnership with CECIL. So welcome all. This will be your host for today. Before we start, let me say that this is a big project that started a long time ago and involved a lot of people. We are here 6 people, me and 5 from the universities. However, along the project, we have several co-workers, researchers, partnerships that work with us in this project. So just here to show you that we are a big team. So a few words about CECIL. As I said, CECIL is a Portuguese cement company. We are in 4 continents. However, we are based in Portugal. We are in Portugal, Tunisia, Lebanon, Angola, Cape Verde, Brazil, the Netherlands, and also Spain. Our main activity is the commercial and production of cement, of course. However, we produce other products like ready-mix concrete, aggregates, mortars, and hydraulic lime. We employ around 2,000 direct employees. However, we have contractors, partnerships within CECIL, and we have around 40 quarries divided by the 8 countries. And of those 40 quarries, we have around 66% of these quarries are active. So just to framework here a little bit about the extractive industry. The extractive industry as divided into quarries and mines. However, for the production of cement and aggregates, we use mainly limestone, clay, and or marl. So, but just to framework, we are classified here in this category. There is the non-energy extractive industry. Just to framework where the extractive industry are. So, just to start this session and break the ice. Of course, it's important your participation on this, your opinion. We have a question here for you. You will use the Mentimeter. So we want to hear from you. What do you think, what you consider are the main impacts for extractive industry on biodiversity and ecosystem service? So Liz, please, can you share the Mentimeter with us? So you have to go to this website. It's easier. You can use your phone. You can use your browser in your computer. So www.mentic.com, and you can put the code and write 1 or 2 or 3 main impacts that you consider most important for the extractive industry regarding biodiversity and ecosystem service.
Sorry, are you seeing my screen now?
Yeah.
I'm sorry.
So yes, so we are good, but we have some answers. So we have land fragmentation, lack of vegetation, pollution, dust, responsibility, biodiversity loss. Nice answers. Pollution, water and air, destruction of habitats, deforestation, always here water, species, habitat loss. Industry are different. So, okay, so we are starting to get more answers. Erosion, noise, good point. Okay, so I think we have, thank you for your feedback, for your answers. We will collect all of the Mentimeter answers. So we will continue, but thank you a lot. I think we have here very good answers. So I'll continue to share my screen. So just a sec, you are seeing my screen, right? Okay, so the question was, what are the main impacts or the potential impacts? And just to resume, the main impacts of regarding extractive industry, mainly on the first stage. We have the visual and ecological impact, we have ecosystem degradation. In the Mentimeter, we had the habitat fragmentation or habitat loss, the removal of soil and vegetation. To assess the raw materials, we need to remove all soil and vegetation. Fauna, we have a direct, indirect impact of the decrease of availability of resources for fauna, pollution also in the Mentimeter, and of course the alteration in topography and hydrology in the quarry area. So let's start talking about restoration projects. So first of all, let me say, and I work with restoration since 2005, and I just want to highlight, it's not easy to rehabilitate, it's not easy to restore, it's a challenge process, and each quarry has its own reality. So we divided restoration projects here in 3 main categories. And just to say that this may vary according to some authors, but we use these 3 types: restoration, where you recreate the reference ecosystem; rehabilitation; and reclamation. Reclamation, you basically change all the land use of the reference ecosystem. And you have here an example. This is a quarry in Portugal, in the north of Portugal, that they built a football stadium inside the quarry. So here is just to highlight that we have several arguments or criteria or variables that influence your restoration project. First of all, ecological value, it's very important, of the area, budgets and resources, especially human resources, social context, safety conditions in the quarry, also important. The exploitation technique is a factor that will limit your rehabilitation project. Your revegetation is very important. Legal obligations that can vary across country. And these stages are very important, in these variables, even in the beginning when you're trying to plan your rehabilitation project, and also during the implementation. Scientific knowledge also important, and not only scientific, you have to have knowledge regarding the restoration and also the exploitation, stakeholders involvement, and surrounding areas. I normally say that for a restoration project, the geographic limit of the quarry should not be the limit of your rehabilitation project. So here, just to highlight the variables that can influence a restoration project. So let's start with our case study that we want to present today, CECIL Outão case study. And we need to hear a little bit of history, because CECIL Outão was the first plant of CECIL Group here in Portugal. And it's a very important plant because it has a lot of history, not only for the industrial side, but also the social side and the environmental side. So it's a very old plant. The first one started in 1904. We have the first study for the actual quarries in 65, but during this time we had other quarries in our property, in CECIL Outão property, and the first landscape rehabilitation plan, together with the exploitation plan, was submitted to the local authorities in 73. So we start the exploitation in 82, and let me say that these are inside this area. CECIL Outão plan has inside a natural park. The total area, the plant facilities, the quarry, that was only created in 76. So at that time, they decided to include the quarries, not only CECIL Outão, because Rehabilitation is an area known because it had some quarries in the natural park, and they decided to include the whole property of CECIL Outão in the natural park. So we begin the exploitation in 82, and we have 2 partnerships, 2 long partnerships, one with the Faculty of Science of the University of Lisbon that started in 98, and after in 2007, we integrate the fauna component and the biodiversity action plan with the University of Évora. So let me explain to you how this started, how we decided to start the exploitation. So the idea in the beginning was to recreate the natural habitats surrounding the quarry that are dominated by Mediterranean vegetation. And the idea is to do the rehabilitation together with the exploitation, and not only in the end of the exploitation. So we basically, since 82 or since the 80s, we have a progressive rehabilitation together with the exploitation. So we start the exploitation from top to bottom. This means the above areas to the top areas, and we leave the above areas available for revegetation or for restoration during the exploitation. We use since the beginning different techniques. We can see here that we start doing benches with platforms with 20 meters high, and we pass also to slopes with 20 meters high in both quarries. So we have two quarries, limestone and marl. And since 2004, we changed the exploitation technique. And nowadays we do this type of landform. So we build slopes and sometimes platforms with 10 meters high. So the revegetation in the beginning were made in the platforms, and nowadays we do the revegetation, the restoration in the surface of the slope. So this is a project, this is a rehabilitation that started in the 80s and has 35 years of rehabilitation. So what happened here? We have different type of habitats with different plant communities, age and cover that has been established since that period of time. So we normally say this is a living laboratory to study the process of ecological succession and of course rehabilitation. It's important. And I tried to bring here to the webinar because we cannot go to the quarries, unfortunately, but I tried to bring some pictures to explain and to show our work in the quarry. So you can see here, this is the limestone area. You can see here the marl area. These are the two quarries. We have, they divide here mostly. And we can see here the revegetation in the platforms in the beginning. So we started at 340 meters above sea level. Nowadays, we are around 130 meters above sea level. And you can see here the revegetation in the slopes with 10 meters high, and here with 20 meters high. So our rehabilitation plan is divided in three main stages. The first stage after the exploitation, of course, is the slope construction and the platform construction. And in this stage, is here that we reintroduce the soil or the substrate. You can see here a picture, the reintroduction of the soil along the slope. And after the reintroduction of the soil, we use two techniques. This stage is the revegetation. We use the hydroseeding, and I know that Elise is speaking a little bit more about that. And after the hydroseeding, we plant trees and shrubs in the surface of the slopes. You can see here the hydroseeding, an example, and a picture after the hydroseeding. So it's important to say that we have an ecological approach regarding this rehabilitation project. Since the beginning, CECIL has its own nursery. Since '83, this is the first nursery that they did at that time to collect and produce the native species. But nowadays, we have a nursery inside the plant facilities, and we produce 17 native species in this nursery. We collect the seeds in the surrounding areas, and we produce here in our nursery. Let me say just we only collect what we need for the rehabilitation. However, we have a big support for the local communities within partnerships and also local schools. So we donate some of these species to the local schools and to the local communities. And here to finalize my presentation, just to show you a little bit about the quarry and these 35 years of rehabilitation. You can see here in the limestone quarry, the platforms. You can see here the restoration that was done in the slopes with 20 meters high. You can see here, this is part of the marl quarry. You can see here the different revegetation in the slopes with 20 meters. You can see here with 10 meters. This here that you see is the rainwater drainage that we create in the quarry using materials from the quarry. This was the first platform that was restored. You can see here one species that is a lepopine. A lepopine was a fast-growing species that they used in the beginning. It's a non-native species. However, we don't use it anymore since 2007, sorry. And here is a part of the beginning of the limestone. You can see here the slopes. You can see here the revegetation in the platforms. We have access to all platforms by car. And now, finish my part, I will pass to Elise Nunes from the Faculty of Science of the University of Lisbon. She worked with us, I don't know, since early beginning of the project, and she will explain a little bit about the process and the studies that have been working with us, especially on vegetation and soil. Elise, the floor is yours, please.
Thank you, Alexandra. So good afternoon to everybody. Are you listening to me? I hope you're listening to me in good conditions. And I hope all of you are feeling comfortable. In this, I noticed that there are already some questions in the chat. So we will take notice on these questions, and in the final of these lectures, you have the opportunity to make these questions yourself, okay? And we'll try to answer to them. So I will, in this second part of the lectures, I will talk mostly about how we've been collaborating with CECIL, looking at the soil component and more specifically to the vegetation component in these restoration projects. So as Alexandra just said, CECIL started the restoration project since 1983. Immediately after the oldest sites were, the exploitation was ceased there. And so nowadays we have been working for more than 30 years with CECIL. So we are a research group from the Faculty of Sciences of the University of Lisbon. And as you can see, we started the first collaboration protocol in 1998. And since then we've been working together until nowadays. But before I talk to you about what are we doing there specifically, it is important to understand what are we talking about when we talk about restoration, because it may have different meanings. I think most of you are aware of these recent initiatives that were launched, the UN Decade on Ecosystem Restoration, a global initiative from the United Nations, and also more recently the Green Deal in Europe. And all of these initiatives highlight the importance to restore ecosystems, because ecosystem degradation has implications for all the sustainable development goals that go from the life quality on Earth and also on aquatic systems to food security, water supply, and so on. But what do we mean when we're talking about restoration? Well, it depends on the first stage, it depends on the level of degradation. When we have a severe degradation, it may require the physical-chemical modification in order to establish or re-establish the nutrient and water cycles and to model terrain in the cases where it is necessary. When this abiotic barrier is not such a big problem, it may require the biological modification, meaning that we may want to introduce some species, for instance, plant species by seeds or planting, and re-establishing the networks between the biotic community. Or in not so severe cases, it may require just an improvement of management. We may be talking about, for instance, ceasing or at least reducing the disturbance cause, or reducing, for instance, land use intensity in the case of agriculture or grazing impacts and so on. So in the case of quarries, we're talking more on these sides of the gradient because we need to start from scratch, meaning from soil. But it depends not only on the degree of degradation, but also on the consensualized goals of the restoration or the mandatory goals in some cases. And actually, in those initiatives that we mentioned, restoration is used in its broader concept, including many approaches such as ecosystem management, nature-based solutions, and so on. So actually, restoration actions may be aimed at reducing the societal impacts of degradation, or repairing, trying to repair ecosystem function. In that case, we may be talking about rehabilitation, or in the 5-star, let's say the 5-star restoration, we would be aiming at recover the native ecosystem that was there previously or there is in the surroundings. But in this broader concept, all of these restoration initiatives try to contribute to reverse the loss of biodiversity, recovering connectivity, ecosystem services, deal with climate change, and in general, improve human well-being, reducing the environmental risks and scarcities. As I told you, in the case of CECIL, because it is a quarry that is within a natural park, we are mostly trying this ecological restoration approach or trying to recover these native ecosystems. And this has implications that we will be talking about. So in the case of CECIL, the main question was about soil, because we were starting from scratch. So in these works I mentioned, we started by studying the soil of not only of the restored sites, the revegetated sites. So we studied a chronosequence from most recent sites to the older ones, which were revegetated like 28 years ago. And we compared some soil characteristics like soil organic matter or pH with the soils from the reference ecosystem. And in this case, the reference ecosystem is this Mediterranean maquis that surrounds the quarry. And as you can see, we still see differences in soil. This is because soil takes a lot of time to reestablish. And because of these results, one of the questions that CECIL addressed and with us was how to improve the soil quality or substrate quality. And in this sense, we made, as a research team, a lot of small-scale trials, for instance, with soil amendments, for instance, with hydrophilic gel that may help the plants to absorb water more easily, or fertilizers to improve soil nutrients, or also mycorrhiza, which are symbiotic relationships that fungus may establish with plants in the roots. And so we did several trials, and these enabled us to recommend some amendments, others not, and the right dosages that would better fit CECIL conditions. Other type of trials were done at the slope level. For instance, in this case, we tried to add municipal solid waste to improve soil organic matter. So some slopes had this amendment and others not. And you can see here in the next slide, for instance, the evolution along time of these slopes. We had some challenges in the way, because the idea of this hydroseeding is mostly to control the erosion of these slopes. And you can see here a comparison of a slope that has not, where we have not aided municipal solid waste, and the one where we did. And what I can tell you now is that although the plant cover was much higher in the second case, which is a good thing, the species that were there that took advantage of this addition were not the native target species that we're aiming at, but mostly opportunistic species and sometimes possibly invasive species. And this brings us to another question, which is, okay, the soil, what can we do about the soil? But now we want to establish the vegetation. And we would like to propose you once again a small exercise. This is, we try to summarize some lessons learned about the soil before the exercise we will propose. So first point is that it requires a lot of time to recover. So whenever possible in your study cases, you should save and use the original topsoil as much as possible, because it has already most of the necessary ingredients for restoration. Also, when using soil amendments, you have to take into account that the results from other studies or even from the suppliers may not match the conditions you have in your site. For instance, in terms of soil type or climate or the species you use, so they may not work as well in your site. Finally, in our case, we have to take into account that the native plants in these Mediterranean environments are adapted to nutrient-poor soils. So when we improve too much the organic matter of the soil, we may be promoting undesired species. Okay, so let's go to the exercise we propose you in the Mentimeter as well. And we would like to ask you, what are, in your opinion, the most important criteria for the choice of plant species to be used in restoration? So I will now change to Mentimeter. Give me just a second, please. So where is it? Here. Okay, sorry. Let's put it like this. Are you seeing my screen? Is it okay?
Yes, Elise, we are seeing, yes.
Okay. So I saw that some of you started to answer earlier. Now we have 4 answers. And let's see what you think about this subject. So there are many of you thinking that nativeness, choosing native species is important. Of course, it depends on the context, but it is a good thing. Also, choosing species that provide food and shelter for fauna, which is interesting because, and also in root type, we're thinking about their role at the ecosystem, not only their identity. Aesthetic criteria may also be important in some cases. Nobody thought about the cost, although you have to consider that as well. So let's see, we have 11 answers until now. Anyone else wants to contribute? So you should go to menti.com as before and insert this code to be able to answer to this query. Okay, so I think that most of you are aware of the importance of choosing native species, which is very important, and also of the importance of the role of these species. And let's give just some more seconds for you to contribute. Okay, I think we have some winners in this criteria. Thank you for participating. And so perhaps now we can continue the lecture talking about these criteria for species selection. Okay, we see here a clear pattern. Looking at nativeness is an important thing. And so, if you excuse me, afterwards we will record your answers to this question. So those of you that are still answering, you're welcome as well. But now I will now change for the presentation again. So where is it? Where is it? Here. Okay, now you're seeing my screen again, right?
Yes, Elise, you can continue. Thank you.
Thank you. So, as most of you noticed in that query, it is really important the criteria we use to select plant species. And we are not talking only about the identity of species, its taxonomic composition. This is important if we want to resemble as much as possible the reference ecosystem. But we also have to take into consideration the functional diversity of these species. And what do I mean with this functional diversity? I mean looking at the characteristics, the traits of the species involved. For instance, species that grow more, this has implications for biomass accumulation, for providing food and shelter for the other organisms, and so on. And this is also related with the ecosystem service of carbon sequestration. The characteristics of the leaves of species have huge implications on nutrient cycling and decomposition that directly influence soil fertility. At the same time, root type is very important for erosion control. The characteristics of flowers and flowering duration, for instance, is important for pollination. So we have to consider not only the species per se, but also their functional attributes that are important to that ecosystem. One other attributes that are also important is how these species respond to disturbance, and we will talk about this in the next slide. So in the collaboration we have with CECIL, we look not only at the species identity, but also if the species that are introduced there, either by seeding or plantings or plantations, are reaching this self-sustainability, meaning if they are reproducing, producing new individuals, this is very important. And also if in the restored sites, we see the colonization from the species that come from the surrounding areas, because this is indication of the biotic fluxes with the surroundings. Finally, the presence of these functional characteristics or functional groups is very important for the resilience of the ecosystem. And in this sense, so the natural vegetation in the surroundings of the quarry is very prone to fire. It is a Mediterranean maquis that is used to deal with fire in this historic evolution. And actually there was a fire in this area in 2004, and some of the revegetated sites at CECIL burned. And what we saw was that most of the vegetation recovered quite quickly because these species were the right ones, because they are adapted to fire. So choosing these species that are adapted to local conditions is quite important, as you may see. So what have we done there? Regarding the species, the species that are seeded there in different mixtures, mainly in slopes, using that hydroseedling technique that Alexandra told you about. It consists of a soup of seeds that are projected in the slopes. And we try different combinations of native and commercial seed mixtures in order to see which were the best mixture for different conditions, okay? And the general conclusions that we wanted to highlight regarding this seeding technique is that the choice of native species is very important for the reasons I told you about. Although it presents some challenges because many of the native species require, for instance, pre-treatments to break the seed dormancy. So you have to take into consideration to improve the success of the establishment of these species, and also the season where you sow, and also take into account that the sowing of these species must be seen as a first step to control erosion, giving space for natural colonization of native species afterwards. Besides the city species, CECIL also produces those seedlings that you saw in its nursery. They are mostly woody native Mediterranean shrubs, but as Alexandra also mentioned, at the beginning of the restoration, CECIL used also Aleppo pine, has a nurse plant because has a fast-growing species. These pines would provide some shadow and would help the other species to establish. But afterwards, what we saw after some time was that the pine became dominant, and therefore it was actually competing with the understory vegetation. And so we did some trials with pine thinning and pine removal, and also advised CECIL not to use the pine, which they did. So nowadays the pine is not used anymore, okay? So lessons learned with these planted species. It may be needed, no matter what type of strategy we use at the beginning, we may need to adapt that strategy using this adaptive management to restore the restoration trajectory, as in the case of pine, okay? Once again, native species play a very important role. And also just to highlight this importance of the provenance of the plants and the seeds. In this case, they become from the natural surroundings, which is quite good. But this is just to tell you that this provenance has a lot of influence on maintaining the genetic heritage that may be important to the resilience of the community. Okay. This is what we have done at the plot level, but we also want to upscale these conclusions to the landscape scale to see the whole picture. And in this case, we aimed at quantifying the ecosystem services provided by the restored ecosystem. For instance, climate and water regulation, carbon sequestration, pollination, and so on. So besides the field indicators that we collect in the field surveys, we also use complementary metrics that are obtained with remote sensing techniques, either LiDAR technologies or with the satellites information. What is this LiDAR technology? Well, probably most of you know, but for those who don't, so LiDAR, that stands for light detection and ranging. It's a device that measures the distance to a target by illuminating that target with laser light and measuring the reflected light. So the differences in the laser return times and the respective wavelengths give you a kind of a 3D image of the vegetation, as you can see here. And this information can give you a lot of information immediately. For instance, plant cover, the spatial heterogeneity, the complexity in the structure, and so on. So we also use this information in, sorry that your faces are in the middle of the presentation. Besides the LiDAR, as I told you, we use a lot of satellite data as well. Why? Because many satellites are able to give you the reflectance pattern of the electromagnetic wave from the areas where they're pointed at. And why is this information useful? Because we know in the reflectance spectrum of light, we know that the vegetation mostly reflects vegetation here in the area of the red and the infrared. And because we know this pattern, we can build many indices related to the vegetation. And this can give us an idea of the quantity, the amount of vegetation, its water content, the health of the plants, and so on. And we can do it retrospectively in time and also compare different periods of time in the same year, different areas, and so on. So to finish, this is the last slide. What we do is we integrate not only the information from LiDAR and satellites, but also with field data, taxonomy, taxonomic diversity, soil, etc., functional diversity of the species. And the final goal is to use modeling approaches to be able to quantify ecosystem services at the landscape level. Okay, so these are some of the tools that we use and that may be used in these contexts. And now I call to the stage my colleague, Pedro Salgueiro, which will be talking about other important components, which are the animals that are in these restored areas. So Pedro, I will cease my presentation. Go ahead, please.
Okay, thank you. I hope you are all seeing the presentation now.
Yes, Pedro, can confirm that.
I apologize in advance because I had a problem with microphone. That only happens in these situations. I'm using Carmo's microphone. So like Alice was saying, I will talk about the fauna component of the project. The project began, the partnership with the University of Évora began in 2007, like Alexandra was saying in the beginning. And we had three main challenges, which were minimizing the impacts of the exploitation, promote the natural processes of colonization, and restore the structure and functioning of ecosystems. The greatest challenge of all was that we must apply this to the animal community, that at the time it wasn't a very studied subject. And one of the main questions, and now I'll ask Alice for the Mentimeter and ask you to answer this question, is why we should approach animal communities in restoration processes. What are their role or importance in the restoration processes?
So I will share. Where is it?
You can go back to the Mentimeter.
I think that the code has changed. So in case you don't find the answer, try to go to menti.com again and use this code, please.
Okay, you start to check here some answers. Biodiversity indicators, good answer. Traffic chain, seed dispersal, pollination, decomposition. Ecological balance, diversity. Okay, very good words. They are sexy, yes, totally agree. Easy to monitor. Okay, I guess we have, even more now. Okay, decomposition, ecological balance, pollination, diversity, control of plagues, natural restoration, maintenance, biodiversity, decomposition, fertilization. Diversity and ecosystem are the words that are standing out. Yes, I think we can go back to the presentation. So I'll be back sharing. So I'll be back sharing my presentation. Okay, most of all I've said it. although it was not the most voted, you talk a lot about ecological processes. And I think when you're considering the animal community, you know that their composition, the structure of the community, and the functions, the ecological interactions the animals maintain with vegetation, allow a set of ecological processes that is the restoration process. This has implications, of course, on vegetation structure, on ecosystem services, and ultimately on the restoration success. So the ultimate question is that, can we have an entirely restored ecosystem without considering animal wildlife? Of course not. And of course, animal wildlife should always be accounted for restoration. So what I'm going to present you now is a roadmap to quarry restoration that we built. This is a draft from several documents that we've been consulting, either guidelines from WBCSD, IUCN, BirdLife, things that we've been looking for, and also some papers. And I'll now explain how the roadmap is built and how we have been interpreting this roadmap, and be responding to each one of these questions and this challenge of the roadmap. So the first question should be made in the pre-quarrying phase, and should outline if there is a biodiversity inventory. This biodiversity inventory is necessary to determine the final use of the quarry, and also to assess the risks and opportunity assessment. What is risks and opportunities? The risks are mainly identify those habitats and species that are most vulnerable to quarrying. Of course, all species and habitats are vulnerable to quarry, but there will be some habitats and species that will be most difficult to restore, and those will be the most vulnerable. And in this situation, we should avoid exploring. But also we can ask for opportunities. Which opportunities can a quarry, can the exploration of a quarry support biodiversity? And we'll be discussing this in slides to come. But these questions of the final use of the quarry is very important, also to establish what the strategy will be. And you can always aim. You can see the figure in the right side of the monitor. You can always aim to a climatic state, to a higher state of naturalness. And here you have to employ ecological restoration measures. It could be assisted or spontaneous. We'll be talking this in the next slide. But you can also explore other alternatives. And these being alternative states that increase heterogeneity and require more intervention, but they can also guarantee much more biodiversity if they manage accordingly. Of course, this graphic of biodiversity is sometimes applied to temperate regions and not tropical regions, where the climatic states are indeed more diverse than intermediate states. But following the intermediate disturbance theory that says that at intermediate disturbances, we will have the most biodiversity, we can always look at the quarries to improve some habitats that may take advantage and that may benefit from these alternative states. And also we can have reclamation. Reclamation can be simply the plantation of trees for wood harvesting. And this can have an important income for companies doing this kind of intervention. But of course, if you're using monocultures, the biodiversity will of course be lower. So after setting the target, you must ask if your ecosystem has the ability to regenerate itself or not. And here there are two main strains that you can talk about. Of course, there are a lot more talking about reclamation and so, but there are main strains regarding spontaneous restoration and active or assisted restoration. In the right side, you can see a graph adapted from the study from Prack and Hobbs, and it's quite succinct. It marks some thresholds where spontaneous succession might be most advantageous, and beyond the thresholds, technical reclamation or assisted restoration will be necessary. So spontaneous succession is seen as an alternative to technical reclamation that will improve pioneer stages of ecological succession, which have their own value. And technical reclamation is viewed only as a necessary complement to restore the quarries. Of course, this as always related to productivity, stress, several indicators that can allow you to select your strategy. If you consider, for example, Outão has a typical Mediterranean climate, and where the summers are very dry and the water is scarce. So plants are of course subjected to a great stress and can only be restored by applying active restoration measures. Regarding the active restoration, active or sister restoration measures, you must identify which actions you want to explore or implement. I divided them here into mitigation and promotion, and these are subscribed in the mitigation hierarchy, which benefit firstly the promotion, which stands for the creation of habitats, creation of conditions to improve biodiversity, or mitigation when the actions address mostly the limiting factors that are identified, the limiting factors that are constraining biodiversity. So I will present now in 5 slides some of the main studies that we've been performing regarding the actions and the themes, the issues that are subjected to this. The first of all is creating new habitat elements. This is a study that we published that regards the species in the photo, which is the black red star. This is a bird species that improve their occurrence, this distribution and the numbers, as an increase along an increase of quarry cover. So this species locates its nests in the cliffs of the quarries that mimic natural cliffs, and therefore quarries were highly and positively selected for this species. But beyond this species, the main question here, and how I was talking about previously, is that as this species benefits from the quarries, a lot of other species will also benefit from quarries if they are managed for. I'll give an example of Arrábida, which is a Natura 2000 site where Outão is situated. And there's an action plan for Arrábida site that says that we should prevent the downfall of habitats related to rocky habitats or to rocky substrates. And quarries may provide that substrate and may provide the evolution of the ecological succession that is one of the most menacing aspects to these habitats. So we can uptake these characteristics, these new elements that the quarries provide, and take advantage from them to benefit some pioneer habitats and pioneer species that are also of conservation concern. Another subject relates to creating temporary habitats, either ponds, rock piles. So these are not areas that are now open for restoration, but areas that are still under exploitation. But if these areas are not being exploited in the moment, they can provide several habitats for nursing amphibians, or for birds to nest, or reptiles to find shelter. So you can always look at the quarry as something in construction, and you can change and manage the quarry itself in order to promote several habitats that can benefit several species. Of course, regarding the mitigation actions, you can always improve habitat conditions, trying to mitigate some factors. What we have here is 3 examples that we've been performing in CECIL: the artificial ponds, which respond to a water scarcity during the dry summer. and we built a water pond and see that the water pond was attracting animals to the restored site during summer, which it was a good result. Also, regarding plant-specific species that correspond to food provisioning or support nesting for birds, or even species that benefit butterflies, because butterflies select very specific host species to lay their eggs and from where caterpillars are feeding on, and also plants that producing flowers and can sustain a higher pollinator community, and we'll check about this later. In another subject about shelter provision, you can always also manage some sites where shelter is limiting, and you can provide nest and bat boxes for birds and bats, of course, but also stone walls and other structures constituted of rocks can also provide habitat for reptiles, and wood piles also benefit small mammals and some insects. Another subject that you must address is if the restored areas are well connected to the natural areas, for two reasons. The first one, because well-connected areas will provide a natural colonization from the natural areas to the restored areas. And we want that to happen. From another subject is that most of these species, and you're talking about mammals and birds, can also transport seeds from the natural area to the restored area, and then increase the spontaneous restoration of the areas, or revegetation in this case. So what we've made here is a study with the wood mouse. We selected a tiny mammal species, and we radio tagged him with a radio transmitter and followed his movements. So each point you see in the figure, you have blue and red and green, sorry, which correspond to two individuals, and you can see that they make use of the restored area right here where you see the cliffs, and the natural area right here. So what happened is that the wood mouse finds shelter in the restored area. There is more availability of shelters for them, but due to food scarcity, in principle, that's what we're thinking of, he makes daily movements to the natural area. So connectivity may not be an issue, it can be improved, yes, but there are other issues that we must address, namely regarding the food availability that exists on the natural area, but does not exist in the restored area. And like I was telling you, we've been addressing also ecosystem services. We have been studying seed dispersal, but also pollination, which is the example that I bring here today. Here you compared how pollination services and ecological networks were in each of these areas: natural, restored, and abandoned area. And what you can see is that there is a lower diversity of plants and highly unbalanced interaction between honeybees and some plants, which does not happen in the restored and abandoned area, where wild bees and bumblebees are also have also an important role. So what you can see here is that there are species that in the natural area that are dominating the network, and other species in the restored and abandoned area that share more of plants and have higher diversity of plants. This may be due to the existence of different plants in the restored and abandoned areas, namely grass plants, which provide a longer availability of floral resources, which makes it available for most species and guarantees many species of wild bees and bumblebees. So we have now here another subject. Following the biodiversity action plan, we must follow also a biodiversity monitoring plan. This will allow to evaluate how the actions have been successful or not, and through an adaptive management, like Elisa already said, we can alter these measures as long as we are going to evaluate them. So what we have here is that each 3 years we will be making we are making monitoring for the several groups of fauna. We have here birds, mammals, reptiles, amphibians, butterflies, and ground beetles, and we've been following them and see how the community evolves. We can also here establish which species are going to be winners or losers. In this case, what you can see here, each column corresponds to a species of each group: ground beetles, butterflies, amphibians, reptiles, birds, and mammals, divided here in three: small mammals, carnivores, and bats. And what you can see here is the relative proportion compared to the reference site or the natural area. So as long as it's green, it's good because it's at the same level same level of abundance seen in the natural area. But as long as you have yellow, you're getting more abundance in the restored areas than the verified in the natural areas. And you can see here from some species, it could be 10 times the abundance of the natural area. If you see the red areas here, you see that these are species lacking in abundance or totally lacking in the restored area. And in blue, species that are appearing uniquely in the restored area and not in the natural area. So you can see here there are a lot of species that are winning in blue and yellow, and species that are losing, mainly these in red, which can sustain marked differences between the natural and the restored area in terms of similarity. And this will introduce this theme, which is the net impact assessment. Net impact, it's a conceptual term that is being imported from economic wording. So what it stands for is that if you have a reference site and then you have an impact on that on the site, you will have a net loss of biodiversity due to that impact. And the idea is that through restoration, you can achieve a no net loss of biodiversity, or even a net positive impact. And here we're talking about restoration, but also sometimes in offsetting. Okay. There are some tools that are already available: the NIA approach from WBCSD, and also the biodiversity indicators and reporting system, the BIRS from IUCN, that can be used and are generally used by non-expert people. But what you've been calculating for the Outão quarry is that we have a net impact that is decreasing, which is good. We want to achieve a no net loss or a zero net impact. And it's now about 0.3, which means that the entire property has a 30% impact over the biodiversity, the expected biodiversity that should be there. But when you look at the number of species, you can see here that the restored area has more species already than the reference site, and mostly due because of this blue square. This blue square, as in the other figure, signifies the species that are not present in the reference site, but are only present at the restored site. So we're creating habitats through the management of the vegetation of the areas, either rocky or either grassland, that do not occur, habitats that occur that do not occur in the natural area or occur more sparsely. We are creating habitat for the establishment of these species that are more rare in the natural area. I don't say that they don't exist. We're not able to detect them because they are possibly rare in the systems. So of course the impact exists. We have a 30% impact over the biodiversity, but we must also account for this new biodiversity that is being created, and this should also value the net impact assessment. Of course, there are also other approaches that we can do because biodiversity concept is a multidimensional concept. It requires the assessment of genes, of species, of ecosystems, of ecological process that we cannot comply into a single indicator. Okay. and this subject requires further investigation. So the roadmap is here. I just put this slide because I think we're later going to provide you the slides, and you get a slide with the old roadmap. So I will now enter in the last 3 slides, and I think these are one of the greatest importance, is how business integrates these scientific studies that I and Elise have been talking about, and how Alexandra, as a bridge, is being able to proceed to changes in the business and in the business strategies regarding the restoration. So I have here a lot of results that we University of Évora and the University of Lisbon have been producing, and also how they've been integrating into business. Due to the time, I don't think I have much time to be addressing all of them. I'll just be mentioning some, like soil amendments that have been providing some changes in the use of hydrophilic gel or the solid waste, like Alice was talking about. Also irrigation, that we don't need to have long-term abundant irrigation, because that will alter the communities, and the irrigation is only applied in critical periods. And also non-native Aleppo pine trees that were used in the beginning of the restoration process are now removed because they have impacts on animal communities as well as the vegetation. Other issues here regarding when to make operations, or where we should avoid nesting season or nursing seasons for several animal species. Some plant species that can be host or fruit bearing, and you can bet on them to increase the attractiveness of the areas for animals. Managing water as a limiting factor, and also reducing the slopes, which would facilitate connectivity for most species. And right now we're working on 10-meter slopes, then on 20-meter slopes. But besides restoration is also how this integrates in the business, in the mentality of who's managing the company. And we've been proceeding to some advances in here. Of course, these are most difficult because they apply economical and policy concepts, but we already passed from a restoration practice that was looking mostly to landscape aesthetics and impact mitigation, and we now have integrated biodiversity assessment and ecological process aiming no net loss or net positive impact. All this we've been discussing, the roadmap and all approaches that we've been developing, intend in the future to develop and apply a strategic plan to integrate biodiversity management into CECIL group. So, and with this, I'll end my presentation. I will now leave space from some questions and answers from you. Whenever you want to start, please. You can write them. I think there were one or so.
Just Pedro, there was just one person that left a question in the chat room. Okay. Sibyl Redmiller, but it was before Alice's presentation, so maybe it was answered. The question was, how diverse are the species planted, and how close to the original vegetation?
Okay. I can talk about the plant species. Pedro also presented that regarding the animal species, in case he wants to say something else about that. One of our concerns is actually to compare the vegetation from the restored or vegetated sites with the natural vegetation. What we have been finding is that for instance, Aleppo pine is one of the main responsible species for the differences we find, not the only one, but one of the most important, because we do not find Aleppo pine in the natural vegetation, but we do on vegetated sites because it was used initially in restoration as a nurse species. But so CECIL is now addressing that issue. They do not plant Aleppo pine anymore, and they are trying to reduce pine density in the restored areas. Although the species that are used in restoration are native species, mostly of them, all of them nowadays, they still have differences regarding the abundance in which they are found in natural and in restored areas. So there are still some differences between the natural vegetation and the restored sites. But what we have been seeing is that the oldest, the restored site, the more similar it is with the natural vegetation. So we've been seeing that the vegetation is evolving in the right direction, becoming more similar with the natural vegetation. That is a good sign. Another good sign is that nowadays we find in the older sites, in the older restored sites, some quite important species for conservation reasons. Species that are rare or that are protected. Some of them are already in the revegetated sites, which is a good sign of biotic fluxes with the surroundings. And I hope with this I answer to the question, but we are available. Pedro, I don't know if you want to add anything.
Well, I think the question regards mostly the vegetation. What I can say is that we've been making that kind of study regarding animal communities, and we're a little bit above the 50% similarity between the communities. This considering the abundance. So the graph of the species, the round graph that I've showed previously on the presentation, shows the main differences, and you can see that there are differences, of course, and I would like to sound that there are winners and losers about this, and of course the intent is to go near the natural areas to increase the naturalness of the area, but we are also taking advantages of some pioneer states to promote some species that only occur in grasslands, for instance, and can benefit from that. Well, I don't know if you have any further questions. You can raise your hand. There's a button here on reactions, or even in the chat where you can raise your hand if you have any question. If you don't, we may proceed to the next part of our presentation. So I'll just wait for a few seconds for you to ask more questions if needed.
Yeah, if you don't have question or just to comment something, you can comment if it's not a direct question. I don't know if we say in the beginning, but we have both quarries have 100 hectares, and we have 45 hectares of rehabilitation since the beginning. So this is the dimension of the rehabilitated area in the quarries. I think it was it was referred on one of the slides, but I don't know if we talk about this.
There is a question from Claudia Brites. Maybe she can pose it herself.
We can answer. It's about the soil restoration and reintroduction.
She's
yes?
speaking. Yeah.
Oh, yeah.
So, Alexandra, do you want to?
Yeah, I can start. Yes, about the process of soil. So we use we have two quarries, limestone and marl. And marl is the substrate that we use from the quarry to reconstruct the slopes. This is the marl. This is the substrate. It's not basically soil, but that's what you use. How we do it, we have certain areas where basically we have this soil stored in the quarry. You can see basically our background has a good example of the reconstruction of soil. And after the exploitation, we start to build the slope. And we have a certain dimension or distance that we have to maintain, and we have a certain angle to maintain the soil. So the slopes don't have higher inclination, but it will vary across the construction of the slope. So we have contractors that do this reconstruction of soil. the reintroduction. However, they are, of course, followed by us, and we try also to maintain an uniform layer of this marl substrate that you use in the quarry. I don't know if I answer. You want to complete?
Yeah, yes, I may add that. So this substrate, it is not structured as a true soil. Of course, it is a substrate, but the idea is that with the introduction of plants, with seeds, and also with planting, they progressively start to contribute to soil stability, to soil properties, to soil organic matter, and so on. So, but soil actually takes a lot of time to improve its characteristics.
Because for the draws that I saw in the examples, you have such an how you say,
inclination. Yeah.
And I was wondering how they kept the soil over there, because with the rain, I suppose that everything will be washed out, and even for develop some amount of roots, of plant roots to fix that substrate that is not soil, because soil has a fauna and a flora and a very complex universe inside it. So and how long it will be until you have like a stabilizada, uma parede stabilizada.
Well, this is like an engineering process, and the people that does this work has knowledge to. That's why one of the variables that is important in a restoration process is knowledge. And the people that work with us has a lot of knowledge in terms of engineering and knows the techniques. And we also have the equipment and the resources to construct the slope. I can guarantee you, we try to construct the slopes in different stages. For example, we have bigger material, okay, in the end of the slopes, and we will reconstruct the slopes with the fine material, okay? But this is basically using engineering techniques and knowledge, and people that has a lot of knowledge on this. We also have we construct also water drains. We construct using materials from the quarry, like from the rocks of limestone. We don't use concrete or anything like this type of materials. And this helps us to control the rain that, of course, it's not a big problem in this quarry, the rain, but also this helps to control erosion. There are some things that we learned from working in the quarry. For example, the importance of the stabilization of the slopes. For example, we normally only construct the slopes in the summer. This is done in the summer, of course. And I don't like to hydroseed everything in the beginning. With the idea is to hydroseed in the next year, but sometimes it's not possible. After the first rain in September, October, it will depend here in Portugal, especially. After the first rain, we sometimes have to correct because we'll damage some parts of the slopes, okay? But we have to correct the construction of the soil, and only after that we will do the hydroseeding. Of course, along the slopes, you have different levels of soil or profundity of soil. Okay, so even in the select species, the plant species, we try to select, for example, in the top of the slope, where the soil is much less in the bottom of the slope. We try to select the species that we plant in the top of the slope or in the beginning of the slope. But to answer the main reason or the important variable is engineering process, and have people that has that knowledge in the quarry to build these slopes. However, after the first year, we had some trouble. It depends of the weather conditions. For example, winters with heavy rain, sometimes we have to reconstruct the slopes. Yes, it's not a factor that occurs a lot, but after the first winter, and especially with hydroseeding, that helps to control erosion. It's a big step on the stability of the slopes. Okay.
There's another question by Sibyl. Maybe she wants to put it personally.
It's a good question.
You have your microphone off. Sibyl, excuse me, your microphone is up. Thank you.
Just delay. I just saw, okay. Yeah, I live in Tanzania and I've been to Bamburi years ago. And of course, like everybody visited this Hala Park, which I think is a very different method of restoring a quarry. I don't know how far you have looked into this example, but of course it's an amazing site today, hugely biodiverse and big mammals and all sorts of ecosystems there. But as I do understand, it was done by more or less one man, Hala, a Swiss guy, biologist who lived there and started with eucalyptus. And then he introduced millipedes, who were the only ones able to consume the spines of eucalyptus and create soil over decades. They created an incredible ecosystem, which I assume may be compared to the original native one, artificial. But of course, probably quite a different example from what you have been doing in your site. Just a question, because I'm just there as a tourist and just loved it, but maybe it's a very different way of doing it.
Elise, I think this question is definitely for you.
Well, I may comment. I do not know that example. I just saw quickly the site, but it looks very interesting. Actually, well, there are different forms to restore, different ways to restore, different goals to attain, depending on all the stakeholders that are involved in that process and what do they aim for the site, right? So all types of restoration in the broad sense, you may do it in the initial stages with different types of species that were not before there. It depends on the context, and you have to know a lot about ecosystems and how they work to try to rebuild from scratch, step by step, to put the right ingredients so that the ecosystem reorganizes itself and actually starts to function and things start to be connected. So that is an interesting example. We will look further into it in more detail, I think. I don't know if you want to complement, Alexandra or Pedro or someone else.
I think it's regarding the chat. We have here the question about hydroseeding also, because we have here my experience that it's often difficult to obtain volume of native grass seeds, and hydroseeding companies often use in a mix or subspecies sourced by farmers and not the local variant. How did you tackle this, and what would be the solution for other waiting to rehabilitate using this methodology? I can start and Elise can finish. I remember when we started doing the trials with the universities, especially regarding the hydroseeding, we have a lot of difficulty to obtain these seeds, especially here in Portugal. So we try to look for suppliers, and some of them have a very high cost for this type of seedings. So it was a process. We started, I don't know, 2007 at least with the project. And I remember that only a few years, 4 or 5 years, we start to establish the composition and try to have good results. And when I mean good results, it's for the ecological process for us as a quarry managers, because of course we have to, if like Elise said, using other compounds, it brings sometimes more insuccess than success. So every factor is important when you're trying to select the seeds for hydroseeding. So I think nowadays we have a good mixture, but the result was time. We need time to study with the university, and also to adapt to the reality of sometimes not only the quarry but each slope.
Just to complement your answer, Alexandra, seeds, finding the native seeds and native propagals, it's a real issue in restoration at a global scale. There are some very important movements nowadays to foster native seeds production, because depending on the country or the region where you are, it may be quite hard to find native seed suppliers. And this is a market area that is expanding, which is a very good thing. And I think it is also an opportunity, because in order to use native species, you have to be able to buy them at reasonable costs. And so this is a big area of interest within restoration. And also another important issue is the provenance, because it's not the same thing as you use varieties from a very different site, from a very different country, or if you use seeds that are collected within your restoration area. These, the maintenance of the genetic heritage may be quite important for the adaptation of species, not only in the current context, but also in future contexts of climate change and so on. So the provenance is always also a hot topic in restoration.
Okay, thank you, Liz. So I know Pedro is making neat signs that we have to go to the breakout rooms. Pedro, can you continue?
Yes. So we have an exercise now for you. You're going to use breakout rooms to gather in small groups. So Anna will be sharing with you an inquiry. It contains three questions. It will be in a document, or in a Word document, or in a PDF. Please use which is best for you. I don't know if you all working with Microsoft Office. So we are all now in the main room. Now we're gonna make some breakout rooms. I think 5 to separate us all. And within each room, we will have to select a spokesman or a spokeswoman and discuss these questions. And then we will gather in the main room 15 minutes after, where the spokesperson will write the main findings in the canvas, and everyone will be able to vote or discuss the main findings.
Pedro is creating the breakout rooms.
Well, actually, we are 22 at the moment, right?
Yeah. So we don't need 6 breakout rooms.
No, I'll be making only 5, and I'm about to open the rooms. So as I was saying, you will have one of us at least orienting the
breakout rooms
discussion. Okay. So see you soon. 15 minutes.
Bye bye. Hi.
Hi. Hi there.
Hello.
Hello again.
In my session, we only get to the number 2 question.
We rushed on the third one, yes.
And then Louise with a lot of discussion.
Okay, there were a lot of people giving up also. I don't know if it relates to their interest in discussing, but I would say that we could advance to the questions. So I'm putting now here the presentation. I will invite you, the spokesperson, to select the room and start writing using the annotation tools. I remind you that you'll have to go to the panel, the tools panel, and select annotate tools is the pencil. And by clicking it, it will open another tools panel where you can write some text or make a stamp. Okay, so please start writing.
Hey, Pedro, I didn't understand before how to do it, and where are you to write down the?
Okay, can you check the toolbar on your Zoom?
Yes,
I think it's in the top. I think
it's in the top. Visualize options.
Okay.
View options. In English, it's view options. In Portuguese, I don't know.
So,
visualizar opções.
Ok.
Pois é, annotate, não é?
Aqui, depois, como é que eu faço isto?
Anotar.
Ok. Pronto, obrigada.
E agora, nada, e agora aparece. Agora, se selecionar, if you select text, you'll be able to write In our case, our room was room number 1, I think.
Okay, thank you, Alice.
So you should write on that square. Okay. Go ahead, Pedro. Sorry.
Sorry.
Costis, I think you were number 5. We were number 5.
Yes. Okay, so I will write your notes. Yeah.
Hi, Costis.
Hi, Alexandra.
Nice to see you.
Nice to see you too. I was just saying
to
Helena that I really miss you, and how nice it is to see you again, and Pedro and all other familiar, let's say, faces that, yeah, we spend a lot of time. Yeah, working on this subject, and also when I visited your nice quarry and your nice natural park over there, what you have created. So I'm really happy to see you.
Nice to see you.
Nice to see you, Costis. Yeah, you have here Pedro also.
I know. Hi, Pedro.
So we have some answers now. I think I can help my room also. Luis, I'm going to help you also. Now it's writing, yeah.
Okay, I see here some of your comments. Everyone else can put some stamps above the comments if you agree with them.
Cláudia?
Sim. Eu não estou a conseguir, para já isto está-me a ocupar a tela toda, eu não consigo. Já consegui minimizar. Pronto, não estava a conseguir minimizar. Então, responder as coisas da primeira pergunta, é isso?
Exato, clicando no texto e na zona do room 1, depois é possível inserir lá o texto. Sorry, I'm speaking in Portuguese, I'm sorry. Insert the text about the room 1, the first question.
Okay. Thank you.
You're welcome.
Actually, I have a meeting right now at 3. I really need to go.
Okay.
So I don't know. Sorry. It was really interesting, and I would love to see them.
Okay, we understand that.
Okay.
Don't worry, Claudia.
Don't worry.
Go ahead.
Thank you, Claudia.
Thank you so much.
Have a nice weekend.
Okay, thank you.
Bye-bye.
Bye-bye, thank you, and keep going well on the meeting.
Thank you.
So the economical is present in many of the...
Yeah, economical, sustainable finance.
Okay, I think that is the main message. I think more economical incentives are in order, so companies can apply in their business policies. Biodiversity. I also want to ask you if more legal requirements from governments are in order. Do you find it necessary, and how it can work for big companies and smaller companies, if that can be suitable for both type of companies?
Not in Portugal.
Okay, if there are no more questions about this, I think you can pass to the second question. I will delete all the drawings, and you will be able to put some new ones.
This will be safe, right, Pedro?
Yes, I already. Sorry, I'm fighting.
You have a good way for drawing.
Not quite. So this is the second question. Please submit your opinion about this. Mm-hmm. Okay, here's some issues addressing social and cultural context. Someone giving quite an importance to local community.
Sorry.
Social benefits of restoration, local environmental conditions. Mm-hmm. Okay. Thank you. I'm sorry for being so fast discussing this part, but since we are quite a few and we're going out of the time we had established it before, and I think you all have other things to do. But if you want to further discuss something else further, we will keep on the meeting for a few minutes later, and we can all discuss this in more detail. So I will now going to pass to the third and last question. So current gaps and future directions. What do you think about this issue? Mm-hmm. Okay. Yes, I think the involvement of local population is something that is lacking. I think, Alexandra, you can refer in Outão. You normally have.
Yeah, we talk about this. Yeah, Pedro, thanks. We talk about this in our room 3.
Mm-hmm. Maybe you want to share it with the rest of the participants?
Yeah, I can share it. You want me to talk, not write, right?
Sorry?
So you want me to talk, right? Not write.
Yeah. Talk about the open the open doors day.
The local, so the open doors week. Yeah, so CECIL Outão, it's a quarry that is very visible from the near city that is Setúbal. So the quarry is basically open to the local community. So it has a big visual impact. And we had a lot of pressure from the community to understand the restoration because it's inside the natural park. So what we did was, since 2004, I think, we had created an open door week. And people can visit during the whole week, and we maintain this type of visit since the beginning with some adjustment and adaptation. But people can visit; it was free. We provide the bus to pick up the people on the city of Setúbal, and they could visit the whole quarry. They can visit also the plant facilities. We did a small presentation in several subjects, not only in quarry rehabilitation, also regarding emissions or even the process of manufacturing cement. So we start doing this with the local community. And in the beginning, we did like an inquiry to the local community, some questions, what they think about by writing, anonymous. And we did also the same inquiry in the end of the visit. And I can say to you that the answers were better after they visit the quarry. So they understand the process, they understand the impacts, the dependence of the raw materials, but it was a very positive tool, this open door weeks that we did with the local community. So here is the suggestion for the participants. I think involving the local communities, be transparent, is essential for the restoration project.
Okay, thank you, Alexandra. We're running out of time, so I'll have to precipitate this to the end. we are about 10 minutes above time. So our idea now is to share our presentations with you. We will gather all this information and disclose it in a workshop report that will be shared with you within a few days. Meanwhile, I would ask you to leave your feedback as is required by the We Value Nature in this site. So I think please, Anna or Carmo, maybe you can put this link in the chat room. And thank you all for participating. It was great for us being here with you and share our perspective with you and further questions that quarry restoration still holds. I don't know if you still want to make further questions or further discussion. We'll still be here for quite a few minutes. Alexandra and Alice, I don't know if you.
Yeah, of course, Pedro. Yes. No, just to
start.
Yeah, I can start. Sorry, Ali. No, go ahead. You, please.
So just to say thank you so much for attending this session. We hope this has been interesting and useful for you. And hopefully we'll meet on future occasions. Okay, thank you so much.
Alice and Pedro, you said it all. Thank you very much for your presence. And I think it was very useful, this session, and happy weekend. Have a nice weekend.
Have a nice weekend.